Okay, friends. All right, page 4, if you would, you will see an activity called modeling so visual. It's perfect since I was a model in high school. Okay, no one really ever laughs at that, but I keep trying every year. Someday. But I do look good in this Davidson. Oh, I look good in this jersey though, right?
Did you get that from like your church or church basketball or something?
No, I just got it because what are the odds that the best player in the NBA went to a college that has the same name as you do? Pretty low. So when that happens, you got to buy it. And I look good in it. And I'm wasting time on video again. Oh, hey, friend. All right. Modeling so visual. So what we're going to do, we're going to do 4 things. This is a lot like what we did the other in class, or in B time. So number 1, we're going to translate the chemical reactions below into chemical formulas. So please try. Number 1 says aluminum plus oxygen goes to aluminum oxide. Try as quick as you can to come up with that thing written out right there, about an inch down on number 4. Try and write aluminum plus oxygen. Did you ever? No, he didn't. You can do. You can do these though. Yep. Diatomic. Yep.
And then put them together?
Yep. But don't write ALO2. Balance their charges and then drop and swap.
I don't know what I'm doing.
Well, do you know the symbol for aluminum?
Yeah,
Then write it under there. Do you know the symbol for oxygen? But oxygen is weird. It always has another one of its friends. So it's called diatomic, or it's O2. Arrow? What do you think these 2 things do? They stick together. So put Al and O. Now, you need to know the charge. You'll need your periodic table probably. Aluminum has a +3 charge. Oxygen has a -2 charge. Then you drop and you swap. Al2O3.
So what do you do with that too?
Well, we're going to do that in a minute.
I hope I got that right. Did I do this right?
I don't know. I'll tell you in a second. Start with the highest coefficient, not in a polyatomic ion, which, oh, you never dropped them. I know, but why write it again?
Because I like to be organized.
Sorry. Undo. My fault. All right. So there's your highest subscript, right? So you have a 3, you have a 2. If you see a 3 and 2, you should use the swapperoo. You want me to help you or walk away annoyed?
No, it's just easy.
The 3 goes in front of the 2. The
Okay.
2 goes in front of the thing that's a 3. So do it.
that with everyone?
No, only if you see a 3 and 2. So do it.
Okay.
3 there. 2 there.
2 in front of this one?
2 in front of that one.
Oh.
How many aluminums does that make?
2. 1. Yes,
2 times 2 is...
Oh, 4.
Just got to put a 4 in front of that.
Ah.
This 3 doesn't exist. That was its charge. It's not down there. Then you would be done. Diatomic, but besides that, it's perfect. O2. Okay, everybody needs the same lesson real fast. It's been a long day of saying the exact same thing over and over. A very long time ago, you had this, and we put 2s in some boxes, and we said a 2 meant what, right up there? Meant it was diatomic. That means when it's alone, you write a little 2 with it. That's why we put a little 2 with it. So everybody look at the oxygen, and you'll notice it has a 2 because it's diatomic, so put a 2. Right there. Now, when this gets turned on, look at the screen. Oh, crap. Oh, well. All right. So now, let me just rewrite this and we'll walk through it together. Now, please listen. You should be okay at this by now. And by the end of the day, you should be good at it. And by Friday, you should be extremely good at it and comfortable with it. And weirdly enough, by Friday, you should almost get a strange joy out of doing it. It's weird. It feels really good when you balance it and you're right. I know it doesn't feel good when you balance it and you're wrong, but rarely the wrong things. I'll just shut up because that's not true either. All right, Al, aluminum. Is it diatomic? No, there's not a 2. Oxygen is an O. Is it diatomic? Yes. Then your arrow. Aluminum and oxygen. If all I have are 2 elements, all they can do is stick together. They form aluminum oxide, which is made out of Al and O. But it's not just ALO, because we have to balance the charges. All right? You need your periodic table to know their charges, unless you have them memorized by now, which some of you will. Aluminum is a +3. Oxygen is a -2. So really, this is Al2O3. Who had that part right? Raise your hands.
What happens to the diatomic too?
All right, look, when something's diatomic, it's only diatomic when it's by itself. In a compound, it's whatever it needs to be to balance charges. Okay? Diatomics are only diatomics when they're alone. All right, now, then we would need to balance the reaction. My good friend in the back laughed at me and said this was the stupidest thing she's ever heard, but I don't care. It will help you. If you see a 3 and 2, you should use the swaparoo. It seems dumb, I'm certainly aware of that, but I don't care. It helps you realize that both of these need to turn into what number to be equal to each other? A 6. So you put a 3 in front of the 2. That 3 swaps. This 2 goes in front of there. That's the swaparoo. Now, that 2 means there's a total of how many aluminums now? 4. Okay. So we've now written it out. We have now balanced it. Rule number 3 says draw the balanced chemical equation into sticks and spheres. You need to do this. It will help you. Now, I cheated. I'm just going to drag all these parts over. Are we ready? So, how many aluminums do I need on the far left? 4. Not hard. 1, 2. Are they connected? 3, 4. I'll answer my own question. I'm super good at that. No, they're not connected. Why are they not connected? Anybody? Okay, because they don't have a number on the bottom or a subscript. There's just 4 independent aluminum atoms. You with me? 4 aluminum atoms that are completely separate from each other. Okay, next. Oh, hold on. All right, next are my 3 O2s. All right, what would an O2 look like? All right, it'd be 2 O's repeated how many times? 3. Now, the 3 things are not connected to each other. It's 3 sets of 2. Then your arrow. Whoops. I screwed up here. Hold on, I got to turn one of these into an infinite clone. You don't care, but trust me. All right. So, now I got to draw this disaster, right? I want you to think about what you've seen before. We've done this before. For a second. Crap. Recording's such a pain in the butt. Ignore the 2. Just think about Al2. We've drawn a structure of 2 to 3 before, and it always looked the same. Just go with me here. We had the thing that were 2 on the top and the bottom. And then we had the 3s smashed in the middle. Are you okay with that picture of that being Al2O3? Okay. Al2O3. Now, I'm not done yet because there's 2 of them. So I'm just going to cheat. And then I would be done. Hold on. Okay, now, this might seem like a lot of work. And if it feels like a lot of work, too bad. It's good for you. All right? You should see balance now. You should see 4 aluminums here, or 4 pink chips, 4 pink chips, and 6 blues, and 3, 6 blues. It's absolutely balanced. The arrow could be turned to an equal sign because the sides are equal, right? Yudi, did I lose you somewhere? Okay. Who's with me so far? Raise your hands.
I got a quick question.
Okay. Yes.
So does that mean you know how there's like those 2 oxygens are bonded together?
Uh-huh.
One of them have to break away
They will break apart.
so there's 3.
Mm-hmm. They would much rather follow this. This will make sense, hopefully, from last lab book. They would much rather steal electrons from aluminum than have to share electrons together. None of us want to share if we can just have, right? So they see that metal, they're like, awesome. They leave each other to go hang out with the metal. Because metals are losers. Okay, we all right with that? Now, step number 4 is to literally build these little things on your desk. And they're not real hard with like the holes in all the springs. They're just little colored chips. And you would build that exactly like that is on your desk so that you have 4 ways to learn it. You read it in words, you write it in equations, you draw it, and you build it. And then you're going to color it in the end. Now, the colors are arbitrary. If you see in bold on that page, it says the correct color is like oxygen's blue. That does not mean oxygen is blue. That's just the chip color we're using to represent oxygen. You okay with that? Last hour someone asked me why calcium was yellow if it was a metal. All right. So now we have CaClO3. See if you can draw the right side of the arrow. Mm-hmm.
I was just stretching, bro. You doing?
That was ugly. Okay, it's not beautiful, but can you see the balance? 2 greens on the left, 2 greens on the right. 1 yellow left, 1 yellow right, 6 blues, 6 blues. Okay. The next two, numbers 3 and 4, please work in groups and complete those. If you're one of those kids that's already done with all of them, that's great. You're smarter than the rest of your friends. Take a nap or do more homework. But most people in here, this is still a little bit of work. Try it, work together, balance charges, draw your pictures, and do what you can.